Okay. Prove that it's the graph. All right. So we need to, just like we did on the other ones, complete the square. Now, I am going to do this. I'm going to draw arrows with these two things. What am I indicating for the... Now, why did I choose the 13? Because it's a constant, right? We've done that on all the other ones where we were completing the square. We moved that constant to the other side. My next question is this. Why did I move the 6x to the other side?
We have x's and y's at the same time.
Okay. What are we truly trying to complete?
The square.
Of what? Of the y's. So the x is in my way. The x is in my way. So now we're going to have y squared plus 2y plus blank equals, and then on the other side we have a 6x minus 13. Okay? How much are we, you need to figure out how much we're adding to both sides right now. B squared over 4a, find me b squared over 4a, so I know how much we're adding to both sides. How much? 1. That is true. B squared over 4 times a does give me a 1. Right, we got A, we got B. Thank you for shutting that off. We heard it. Okay, so we do end up having, we're adding a 1 to both sides. All right, so. Sorry, did I do something that confused you? Okay. All right, so I need you to factor that. What does that factor into? Y plus 1. Quantity squared. Yes. Equals. What's on the other side? 6x minus 12. Okay, yes, I hear you. Yes, I hear you. And I'm not going to take it out on a date, but I am going to take it out. You're right. Okay. What is this going to be if I take out the 6?
Minus 2.
Minus 2.
Heck yes.
Okay, and we need to practice graphing, as some are not in the habit of doing. Yeah. What's the center? No!
It's 2. Negative.
There is no center. That was a trick. I trapped you guys. Stop falling for that. Stop falling for that crap. What's the vertex?
2 and negative 1.
2, negative 1. Thank you so much. I say I'm at the... Yeah, right. Listen to the question.
Why do we always just do fractions?
What do you mean? Oh, I see what you're getting at. I was like, what? 2 and negative 1 don't seem like weird fractions. Okay, so folks, we got our graph here. I probably better zoom in because my fingers are too big for this. 2 and negative 1. Okay, that's my vertex. What's 4p again? 6. So that's 1p is 1.5. Thank you very much. How did I get 4p? 4p is right here. That's right. That's what 4p is. All right. The equation says y minus k quantity squared equals 4p times x minus h. So the 4p is the 6. The p we divided by 4 and we got 1.5. Here, I'll zoom in and show you. Divided by 4, divided by 4. Dun, dun, dun. Okay, let's not do that again. Weird. Yeah. Okay, so now we know that. Which way, based upon this equation, do we know that it's opening? We got a positive. All right, that's positive. And it is a y squared, so that means it's opening either left or right. Because that's positive, we know it's opening right. To the right, to the right, to the right. Okay, so we know it's going to be opening right. Now my focal width may be way off here, folks, so I'm just kind of getting an estimate. I'll erase that little green one here in a minute. Because I just want to know which direction. And then now I need to find my focus. Okay? Where's my focus in life? How far do I go to the right to find my focus? 1.5. There's my focus. Yeah, my letter V is in the way.
So from this center, you go 1.5 out. Right?
Okay, so the focal width is the 4p. So we used P right there to go that distance.
So we use the center.
How far? Okay, so 4p was what? 4p equals 6, right? How far up and how far down should I go to find points? 3 units. So I got 1, 2, 3. 1, 2, 3. Oops. Dun, dun, dun. Wait till I get it corrected here. So we know that this is doing something like this. Okay, if we know that the focal width is 6, focal width is 6.
You just take half of that.
Right, you take half of it one way and half of it the other way.
So if it was a 3, then you just put 1.5.
You do 1.5 one way, 1.5 the other.
What is focal length? I didn't put that in my notes. I could not figure out.
Focal length is what they call P. That's the focal length.
Oh, well.
Okay, that's the distance from the, whoops, sorry. That's the distance from the vertex to the focus. Okay, can you tell me what the directrix is?
Yeah.
Y equals what?
1/2.
Okay, y equals 1/2. Let me draw. I will attempt to draw. I'm going to use a solid line for this. If I could choose a different color, that'd be nice.
Choose purple.
Y equals 1/2, which is the directrix you just quoted me, is right there. Y equals 1/2. Is that correct?
I don't know how you say this.
No, it's supposed to go X equals 1.
Oh, you meant x equals. Oh, okay. All right. Well, let's get rid of that because that was all confusing. Why is that blue? Okay, thank you. So, how did you get this line, x equals?
You went back by the
We used the P and we went back 1.5 units. What? What are we complaining about?
I was just asking if we could.
Not now. Okay.
What's the 1.5?
The 1.5 is the distance that we call P. And we use it a couple different times there. Okay. If we get time, we're going to look up some history. If we get time, we're going to look up the history of why the focal width had a different name. The focal width, that's the nice name, except if you spell the O with an E, that's totally different. But the and you're gonna laugh even more when the other name, okay? The other, yeah, I don't know if they did. They didn't catch it. Okay, maybe the people at home, you know. I said it focal width, you know, if you misspelled the O with an E. Never mind. Okay, so. Oh, okay. There's a middle school kid. Okay, now, the other name for the focal width is the latus rectum. That's right, folks. We're going to have to look up the history on that one. I'm sure we're going to get a lesson from somebody, maybe our local Latin person. How did I know that? Because when I was in school, that's what they called it.
Why is it?
Okay, it's a mathematical term. I don't know where it comes from. I'll need to look it up. Why do we need it? Well, no, what?
With the lattice breakdown where it came from.
Because it's kind of funny. All right, now.
Wait, why is it x equals 1.5 since you went backwards 1.5?
Okay,
You know how you
right, but the vertex is 1.5 units away from the focus. It's 1.5 units away from the directrix.
I have a question.
That has nothing to do with the focal width, if that's what you're asking me. I mean, yes, we use
3.
the focal width is 6. It says,
But you take it in half.
well, that's because from the focal width you go up 3 and down 3, right? To find 2 points, one on one side and one on the other, so you can sketch the graph. Okay, how did we get this?
Yeah.
Okay, they told me to walk backwards 1.5 units from 2, -1. That's how we got there. Yes, Miss Hans.
Do you have to draw a little line that shows the focal length?
No. I'm demonstrating that. Miss Hans had a good question. Do I have to draw a line
Wait, I don't
for
want
the
you to know
focal
my
width?
last name in the video.
And then what?
You can't say my name in the video.
Why?
We have consent.
Did you want me to use your nickname? I was trying to be kind because I thought, that I had teased you enough about that.
No, just don't use any name.
Oh,
Why? Why are you
okay.
doing like that?
This nameless child in front of me. Okay, it's probably tough at home, Come on, nameless child, let's go. All right, now. So here's an example that we were talking about earlier of a searchlight. Same idea as a flashlight or a headlight. The parabolas on the back side of it. Is there a question?
No.
Okay, I was going to say I can help if there is.
No, I understand everything.
Yeah, we can pause and talk about it.
Okay, I'm getting a little bit tired right now. Let's focus on what we're doing. Okay? If you can't control, seriously? I'm like, okay, so radio telescope is another example of when they're taking the signals and sending them out and hitting the parabolic dish and sending them on. And as I talked about earlier, this one's where it's coming in. I wasn't thinking. Just like the satellite dish on the top of your house. When the signals come in, they hit this side and they all focus their attention or their signal straight to. That's actually labeled, if you are looking at any applications, sometimes they call it the feed horn. I don't know how I got that name, but anyway, it's receiving the signal, and that's how you end up with your satellite television and things like that. So all different sorts of. So here's example 6. You've got this parabola. If you're reading through the story problem, I included the picture for you to help you. On the side, we might not show you this picture. There might not be any picture there at all for you, just the story problem. On the sidelines of each televised football games, the FBTV network uses a parabolic reflector with a microphone. I don't know if you've seen people standing on the sidelines with those parabolic microphones. Okay? They're trying to, that's how they get some of that feed, those conversations that are happening out on the football field, is because they're zeroing in that and trying to get that sound to generate into that one microphone. Yes, sir?
Are you talking about those big circle clear things?
Right, that they're holding on the side. That's a paraboloid. Okay, that's a parabolic dish. I'll find one for you over lunch and show you. But it's a parabolic dish, and they're receiving sound, and they're recording that information. So you'd think the New England Patriots would be all over that, Okay. They use these things in different locations. I've actually thought about making a large one of these and using it to send sound waves across the field. But, you know, that was more diabolical in nature.
Where's the microphone in relation to the reflector?
So, the microphone, where do you think it is in relationship to the parabolic dish?
Halfway. Out.
Where do you think the microphone is on a parabolic dish?
Right in the middle.
Not at the vertex. Good try.
At
At the focus. The focus is the microphone. All right? You cheated. Why? Just look at the picture.
I am looking at pictures.
Well, any of the pictures that I showed you here would kind of give that one away. All right? Now, we got a parabolic reflector with a microphone at the reflector's focus to capture the conversations among players on the field. If the parabolic reflector is 3 feet across and 1 foot deep, where should the microphone be placed? Folks, given the information that they have handed you, did they give you... it's probably going to look like this on a test question. No, nobody's going to give you the answer. You're going to have to figure it out. I'm not sure I understand the question. Now, it would be super nice if you put a parabola on a graph. And so you might be asking me questions like, well, how should I do that? Where do you think the easiest vertex would be to pick? 0, 0. You're right. So they picked the easiest looking picture they could make. Now, why did they do this? I guess I should zoom in on this. Why in the world did they make this coordinate 1.5, comma 1? How do they know that? Okay, so it's 3 feet across here, right? And it's 1 foot deep. Okay, so that makes sense. So do we know enough information on here to figure this out? Let's see. We know it's probably something like x squared equals 4py, right? Because we know this thing. Based on the way that we drew the picture, we drew it so that it opened up or down, right? We chose up. Just to make it easy for us. Now, could somebody have chosen right? They could still get the correct answer if they chose right. That's not going to change the answer. Yes, Miss Johnson?
So would the 4P be like the 3 feet across?
I don't think that we can assume that the 4P is the 3 foot across. I don't think we can. Do we have any coordinates on the parabola that we could plug into this equation? We could plug in 0, 0. Man, that's true. But is it going to help us if I plug 0 in for x and 0 in for y?
Probably not.
Probably not. Okay, do we have any other coordinates that might be more useful?
1.5.
1.5 and 1. So right now, oops, did I do that backwards? I did. I did. Oh, no, I didn't. Yeah, I did. I can't think. 1.5 squared over there, and the y value is 1. Okay, find me the value of p. Find me the value of p. All right, so folks, hopefully you divide by 4 on both sides, and what do you get?
5.
Now, some of you got 0.56, and others of you probably did the fraction 9/16.
A fraction.
No, I'm just saying they got 2 1/4, right? 2 1/4 over 4. You multiply the top and the bottom by 4, and you get 9/16. But, you know, I'm not going to... Complicated? What? Multiplying by 4? The top and the bottom?
You can't get that. I don't think you should use that. I shouldn't get this.
So, that's what you need to do on those questions. You do not... I know that you've got to make your own graph. Make the graph as simple as possible. Start with it at the vertex. Make sure you have, that it's 3 feet wide and 1 foot deep. And then that will give you the coordinate you need to use. Okay?
What if they ask us to find the equation for that?
Okay, if they ask me to find the equation for that, give me the equation. Give me the exact equation for the one that I have pictured up here. That's a good question. Let's see what they got.
Well, I was actually got on the answer.
I know, they are going to help us. You need to think about it. Write the equation. Write the equation for this particular parabola.
So it'd be
I mean, I got you started right up the top. It shouldn't be that much to plug in something.
is it gonna be just the same thing as y minus k squared?
Well, we already know what h and k are, 0, 0, based on the way we chose the graph,
Yeah,
right?
but it's gonna be the same thing, except we're just gonna plug in the numbers in there, right?
What's the only thing that you have to substitute to answer my question? I need 4p, don't I?
Which is
Do you know what 4p is?
yeah,
2 1/4, right?
2.5.
Right, 2 1/4. So what's my equation?
So you know too much about math. You taught me on my brain.
There you go. You got it.
Why is it not the 0.56?
Because that's 1p. You want 4p, right?
So the equation would go x squared.
What's the question?
Absolutely not how you did that.
Did you have a question?
How do you
Okay, homework questions. Where do you want to go on this? Let's get some homework questions. 15. Let me get myself set up here. Okay, so 15 is where we need to go. Okay, cool. So question 15. What's the first thing we should do? Draw a picture. 1, 2, 3, 4, 5. So we know that's the directrix. Well, I try to be. And up 5 for the focus. Any idea what the vertex is? Ooh, nice. 0, 0. Boy, that was kind of them. How do we know that's the vertex? It's halfway between, right? Okay. Which way does this open? Up, down, left, or right? It opens up.
Going up.
So we do know this. I don't know if that's a good-looking picture or a bad-looking picture at this point. Do you know the value of P? 5. Good call. Ow. The distance from the focus to the vertex, or from the vertex to the directrix. Okay, the vertex is smack dab in the middle, right?
Yes.
Okay, so P is defined to be the distance either from the vertex to the focus or from the vertex to the directrix, whichever you choose. It's the same distance. Okay, so what's 4P? 20. Okay. So I think my picture's probably going to be wrong there. How far right and how far left do I need to go from the focus? Whatever that means. How far right and how far left? 10 units. 10 units that way. Right? And 10 units this way. To find my picture. Yeah, go ahead. How'd I get to 20? Well, we took this p value and we multiplied by 4 on both sides.
Okay.
Yeah, but you see how we did it then, right?
Yeah.
Okay, Miss Johnson, what's your question?
Okay, so if it's for the directrix, if it's y equals, then the one that's
Horizontal, yes. Yes. Just because we call it the nickname is the y-axis. And that confuses kids over the years. Yes, I've seen that happen. Okay. So we got our picture so far. Okay, is this going to be x squared or y squared? X squared equals something y. Okay, when it opens up and down, okay, so your up and down, those are the ones from that we did last year that reminded you something like this. Y equals ax squared. Does that look more familiar from what you did last year in Algebra 2? Okay, so I realize they wrote it, they write it a little bit differently. Okay, the left and right ones would switch x and y. So your left and right ones, well, that's not what I wanted. Would be your x equals like ay squared, something like that. All right, now, okay, Miss Johnson. Yeah, I haven't finished this one yet, but yeah. No, because I don't have an equation. I'm close. What goes? 20. Now, is that a positive 20 or a negative 20? Positive because it opens up. And we know that because we drew the picture. All right. All right. Always draw those pictures. Helps out a lot. Yes. All right. What was the next one you said? 23 and 3. Okay. Let me go back to 3 first, and then I'll go to 23. Okay, so we got 3 here. Find the vertex. Okay, so the vertex is what? -3, +2. Now, a lot of kids mix that up because they don't look at the letter choices to decide what's going on with x and y. Okay? So, -3, +2. 1, 2, 3, 1, 2. Okay, so that's my vertex. Which way does this thing open? It is going to the right, okay, because it is of the x equals y squared variety. That's the variety we're looking at here, and because that's, what's the question? I'm trying to really help you so that you can decide what's going on here, and some of you are not paying attention at all. And okay, so if the value here is positive, what is that telling me? It's either up or right, and since we're doing the left and right kind, it has to be to the right. So we know that this is doing something like this. It's y squared equals x, right? That is your left and right kind, and then you have to pay attention to that value in front of the x side, or that linear side, to know whether it's right or left. Since it's positive, we're going to the right. All right? Does anybody know what 4p the focal width is? It is +4, right? What does that mean about 1p? It's 1. So, if I go 1 unit in from the vertex, is that the focus or the directrix? That is the focus. Right? And so that is the point -2, +2. And how far outside of the parabola should I go to find the vertex or directrix? 1 unit. So we know that this equation is what? X equals -4. And then we asked for the focal width, but we already have that over here, right? There's your focal width. Also known on the street as the lattice rectum. The lattice rectum.
Are you still having homework?
Yes.